Hello, I'm Teacher Teddy. I teach mathematics and physics at Bosco Secondary School. So today, our topic of discussion is a Form 4 topic known as X-rays. X-rays. This is a Form 4 topic. Form 4. X-rays. Today being the 1st of April 2020. 1st of April 2020. So before we talk about X-rays, let's flash back whatever we had learned sometimes in Form 2. In Form 2, we had talked about a topic known as waves. Waves. How had we defined waves? In Form 2, we learned that waves refers to transmission of mechanical disturbance through medium, where medium can be air, can be liquid, or gases. Apart from that, we had also learned that in wave transmission or wave motion, particles of medium do not always undergo translational motion. Now, in the same topic, we had classified waves in two major categories, namely mechanical waves and electromagnetic waves. Waves. Now, in this topic, we had defined electromagnetic waves as types of waves that can be transmitted even in the absence of material medium. That is, this type of waves, electromagnetic waves, can be propagated even through vacuum without medium. When we were learning on this, we had highlighted various examples of electromagnetic waves, and they include microwaves. We had also talked about radio waves, UV light, gamma rays. We had talked about infrared radiation, visible light, as well as X-rays. X-rays, radiation, which will be our main topic of discussion today. So this was just a preview of whatever we had learned some times back. So from this concept, we had agreed that X-rays is an example of electromagnetic waves. Now, how can we define X-rays? How can we define X-rays? If you are asked to define X-rays, we can just say that X-rays is, or X-ray radiation is a type of electromagnetic wave that is produced when fast moving electrons are stopped suddenly by a metal target. So that is the definition of the term X-rays. X-rays is a type of electromagnetic wave that is produced when fast-moving electrons are stopped suddenly by a metal target. Now, how can we obtain X-rays? That is production of X-rays. Production of X-rays. Now, X-rays are produced by a special tube known as X-ray tube. X-rays or X-ray radiation is produced by a special device known as X-ray tube. X-ray tube. Here we have a diagram that illustrates some of the components of X-ray tube. Like here you can see we have an X-ray tube connected to a step-down transformer. We also have the cooling fins. We have oil flowing in and out through the target, that is. We also have a cathode. Apart from that, we also have the anode. Apart from that, you can see here we have electron beam. We have the heater circuit, focusing beam. So we want to explain how is this device designed to produce X-ray radiation. Now, in this device, that is X-ray tube, one thing you must know is that when current flows through the filament, heat energy is produced, and this heat energy produced enables electrons to be liberated or to be dislodged from the cathode. These electrons are then attracted by the anode, since the anode, which is the copper here, anode, and the cathode are at high potential difference. So that process whereby electrons are being emitted from the metal surface by subjecting the metal to high temperature is what we call thermionic emission. So we can state down that when current flow through the filament, the temperature of the filament increases. The temperature of the filament increases. This increase in temperature, enables electrons to be liberated or ejected from the cathode by a process known as thermionic emission. So you may be asked, define the term thermionic emission. Thermionic emission, from this explanation, simply refers to a process whereby electrons are liberated or ejected from the metal surface by subjecting a metal to high temperature. Now, here we state that when current flows through the filament, the temperature of the filament increases. You may ask yourself, why do the temperature increase? This is because the filament here is designed with a wire of high resistance. So as current flows through it, due to its resistance, heat energy is produced. Now, how is this X-ray tube designed so as to enhance its efficiency in X-ray radiation production. Now, let's talk about it in brief. If you check on the diagram, or we can write a subheading, properties of X-ray tube. Properties of X-ray tube. Now, if you check on that tube, you will notice that the cathode where we have the heating filament, the cathode is concave in shape. The cathode is concave in shape. Now, what is the advantage of this? This is to focus the electron beam to the anode. Apart from that, the anode, which is copper metal in that case, together with the cathode are at high potential difference. Yes, the anode in bracket target and the cathode are at high potential difference. Now, what is the advantage of the two being at high potential difference? So, this is to accelerate electrons ejected from the cathode towards the target. So, this is to accelerate the electron beam towards the target. So that is the reason as to why the two, the anode and the cathode, are at high potential difference. Now, what else are you supposed to know about X-ray tube? If you check here, we are labeled here that inside the tube is vacuum. Meaning there is no presence of air or any gas. So in that case, we say the tube is evacuated. Now, what is the advantage of the tube being evacuated? This is to prevent the collision between the electrons and air particles, thus lowering their kinetic energy. That is the reason as to why inside the tube is a vacuum, or the tube is evacuated, to minimize any collision between the electron beam and air particle, which may lower their kinetic energy. Now, apart from that, if you check on the target is made of tungsten. Embedded on copper. That is another property of X-ray tube. Now, what are you supposed to know? During X-ray production, not all the kinetic energy of the electrons are transformed to X-ray, but just 0.5% of the kinetic energy of this electron beam is converted to X-ray. Now, where do the remaining 99.5% of this kinetic energy goes to? This is converted to heat energy. So, we can note down that during X-ray production, only 0.5% of the kinetic energy of electron beam is converted to X-ray radiation. The remaining percentage, the remaining energy is converted or transformed to heat, at times you say thermal energy. Now, since most of the percentage of this kinetic energy is converted to heat energy, the target is always designed with a metal of high melting point. So we say that since most of the kinetic energy is converted to heat energy, the target is always designed with a metal of high melting point. High melting point. Such as tungsten, or at times we use molybdenum, such as tungsten or molybdenum. Now, apart from that, if you can check on our diagram, you'll notice that this target is embedded on copper metal. Why do we use copper? The target is embedded on copper rod. This is to enhance heat dissipation, heat loss, or heat dissipation, to enhance heat loss or heat dissipation. Now, apart from that, how is heat loss also maximized? In this case, we have oil flowing through, in and out of the anode. Why do we use oil? To enhance heat loss. Apart from that, we also have the cooling fins. All these are to maximize heat dissipation, which may also lower chances of the target undergoing melting. So those are some of the properties of X-ray tube. Now, what else are you supposed to know? In modern X-ray tube, in modern X-ray tube, in modern X-ray tube, the target is always designed in a way that it keeps on rotating. It keeps on rotating. Now, why is it necessary? This is to minimize tear and wear. Tear and wear. This is to minimize tear and wear. That's why most of the parts will be struck by the electron beam at a given period of time. So by the target being in a state of rotation, it minimizes chances of the target undergoing tear and wear. So those are some of the key components of X-ray tube and how it works. Now, what else are you supposed to talk about based on X-rays? So let's talk about properties of X-rays. 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 Now, some of the properties of X-rays that we should know is that X-ray radiation is not affected by both electric field and magnetic field. Electric field and magnetic field. Why is it that X-ray is not affected by both electric and magnetic field? This is because X-rays radiation do not carry charges. This is because X-ray radiation has no charge. That's why we say they are not affected by both electric field and magnetic field. What are the other property of X-ray? Is that they can penetrate through matter. They can penetrate. They can penetrate through matter, except those with high densities, such as lead sheet. Yes, lead is a type of metal with very high density. So X-ray radiation can penetrate through other matter. But when it comes to materials with high densities, such as lead sheet, they are not able to penetrate. Apart from that, they can also cause ionization of air. They can cause ionization of air. Now, what do you understand by the term ionization of air? This simply refers to a process whereby air particles are made to acquire charges, making air particles to possess charges. That is what we call ionization of air. Apart from that, they also cause photographic emission. They can cause photographic emulsion. A process which is used in X-ray photography. Now, apart from these properties of X-rays, there are also others that we can also state. For example, X-rays or X-ray radiation can also cause photoelectric emission. Now, what is photoelectric emission? This is a process whereby electrons are dislodged from the metal surface by subjecting the metal to high frequency radiation. That is known as photoelectric effect. What else are you supposed to know about X-rays? Is that they cause fluorescence in certain substances. They cause fluorescence in certain substances. Such as zinc sulfide. Now, what do this implicate? When zinc sulfide is subjected to X-ray, what happens? It glows or it produces light. So that process whereby zinc sulfide glow or produce light when subjected to a stream of X-ray radiation, we say it undergoes fluorescence or it fluoresces, it produces light, it emits light. Now, X-ray being electromagnetic in nature, they can be diffracted, apart from that, refracted, reflected, and even they can be polarized or they can undergo polarization. They can undergo polarization. So those are some of the properties of wave. One which is very much important, which we've not stated, is that they travel in straight line. At a speed of light. At a speed of light through vacuum. And this is always known as the speed of light through a vacuum is a constant, approximately 300 million meters per second, which is the same as 3.0 times 10 power 8 meters per second. So X-ray also travel at a speed of light through vacuum. So these are some of the concepts you should know based on X-ray tube. Now, before we proceed from that point, how can the concept we've learned be tested? One, you may be asked, define X-ray. We had defined X-rays by saying that X-ray is a type of electromagnetic wave that is produced when fast-moving electrons are stopped suddenly by a metal target. Apart from that, what else can be tested based on this topic is how is X-ray produced? X-ray is produced by a special tube known as X-ray tube. Now, how is X-ray tube produced? How do X-ray tube produce X-rays? When current flows through the filament, the temperature of the filament increases. As a result of this, electrons are liberated or ejected from the cathode due to high temperature. Now, since the anode and the cathode are at high potential difference, these electrons are accelerated towards the anode. In the process, the kinetic energy of these electrons is transformed into X-ray and heat energy. So just 0.5% of the kinetic energy of electron beam is transformed into X-ray, as the remaining percentage is converted to heat energy. Now, what else are you supposed to know based on whatever we've covered today? Properties of X-ray. You may be asked a question. Explain why the X-ray tube is evacuated. This is to minimize any collision between the electron and air particles, thus lowering their kinetic energy. Apart from that, what are the roles of oil and cooling fins? These are to enhance efficient heat dissipation, or dissipation, that is, heat loss. These are just to maximize heat loss, thus preventing tungsten or the target from melting. Now, why do we use tungsten instead of any other type of metal? This is because the target here, which is made of tungsten, tungsten has a high melting point. So in as much as 99.5% of the kinetic energy is converted to thermal or heat energy, tungsten still cannot melt easily. Now, why is it embedded on the copper? This is because copper is a good conductor, therefore enhance efficient heat dissipation. Those are some of the questions that you can be asked based on this diagram. Apart from that, explain why the cathode is designed in a concave shape. This is to focus electron beam onto the target. So those are some of the commonly asked questions based on this diagram. Apart from that, we've also talked about properties of waves. We said that they are not affected by both magnetic and electric field. Why? Because they do not carry any charge. Apart from that, they can penetrate through matter, except those with high densities, such as lead sheet. Apart from that, they cause ionization of air, What had we talked about ionization of air? This is just a process whereby air particles are made to acquire charges. X-ray radiation can cause photoelectric emission. What is photoelectric emission? A process whereby electrons are dislodged from the metal surface by use of high frequency radiation. They cause fluorescence in certain substances such as zinc sulfide. The term fluoresce simply means they glow or produce light. X-ray being electromagnetic in nature, they can be diffracted, refracted, they can be reflected, and even they can undergo polarization. Some of these properties of waves were discussed when you were in Form 3 under waves 2. They travel in straight line at the speed of light through vacuum. Speed of light through vacuum is approximately 300 million meters per second. That is 3.0 times 10 power 8 meters per second. So far, we shall stop at that point today, and in our next lesson we shall pick on energy transferred by X-ray. Thank you very much.